The sun is shining outside the window. Let us slowly open the door to the future together. Hello, my name is Kelly of Mans International. This is our third episode of Chip Series. In this episode, I'll give you a review of the latest research and development of chip from the perspective of the processing technology. Let me first ask you, what is the most valuable asset recognized globally in the 21st century? It is data. At present, the data exchange between main machine and machine-to-machine channels consumes 9% of the world's energy, and it is increasing every year at a rate of 20 to 30%. Moreover, the deployment of the fast data network and Internet of Things is increasing. In this continuously connected world, data traffic has approached the bandwidth limit of communication networks, and high-speed optical communication is urgently needed. Researchers at the Swiss Federal Institute of Technology Zurich have been working on a chip for nearly 20 years. On this chip, fast electronic signals can be directly converted into ultra-fast optical signals with almost no signal quality loss. By the way, this project is part of the European Horizon 2020 research project. This chip will greatly improve the efficiency of optical communication infrastructures, such as optical fiber networks that use light to transmit data. In the past, researchers have tried a method called overall collaborative integration. Simply put, it is to put the electronic chip and photonic chip in layers and press them as tightly as possible to shorten the path and reduce the loss of signal quality. However, the monolithic method failed because of the size of the photonic chip is much larger than that of the electronic chip, and it is impossible to combine them into the same chip. In 2019, researchers at Zurich overcame the size difference between photonics and electronics by replacing photonics with plasma. Since plasma chips are smaller than electronic chips, they can actually be manufactured more compactly. You may ask, has this chip been commercialized? Here I want to introduce a startup company named Versics. It is led by Marc-Rig Escalay, a physicist at the Institute of Quantum Electronics at Zurich. Versics is his innovative project as an Ed Pioneer Fellowship. Versics is the abbreviation of multifunctional optics. The technology has many applications and can be used for satellite communications in the near future. The first marketable prototype is expected to be launched at the end of this year, 2021. We know that fiber optic cables are only the half world of data traffic. The information needs to be encoded and decoded. This means that it must be written into optical signals and then read again at the end. Mark and his colleagues find a way to write this information more efficiently than before. They choose the best materials in the field of photonics and microelectronics to manufacture microchips. The first is silicon, which is the most important material in the computer industry. As a semiconductor, it is very suitable for building circuits, such as circuits on computer and mobile phone chips. In crystalline form, silicon is also used in optical chips to transmit light waves. This has practical advantages because the manufacture of the microformats is already very mature in the field of microelectronics. However, for optical purpose, silicon is far from the best choice. Lithium nowadays offers more advantageous properties. For example, it can work in a wider range of optical frequencies. I will put the specific tech details in my blog. This chip consumes less energy and processes signals at least twice as fast as commercial alternatives currently in existence. If you have been viewing this video for the first time, you're welcome to subscribe to the KellyOnTech channel and learn about cutting-edge technologies and promising startup companies around the world easily.